This problem is very similar to the previous one. We're just given different things and asked to find a different thing. So this time we are asked to determine the coefficient of friction, kinetic friction. So the steps are going to be in a little bit of a different order. The coefficient of kinetic friction, that's related to forces in Newton's laws. So that's going to be coming at the end. So now we're going to start with some kinematic stuff, some big five stuff. So at the beginning, they say it starts at 8 meters per second, right? Has a displacement of 4.0 meters and comes to a stop. So that's three values given about the kinematics of this box. So we can use the big five to find any of the other kinematic values. And what's the one we're going to want to find out? Acceleration. Acceleration. So that'll be the first part, find the acceleration. Using kinematics. A lot of these problems, one of the major steps is often finding the acceleration. Comes to a stop means V2 is 0. Okay, so the big five formula that contains those four variables would be the last one. Crossing out V2 because it's 0. And then isolating for acceleration, I will subtract V1 squared and divide by 2 and divide by displacement. Okay, this mental math's not bad. It'll be -8 because 2 times 4 is 8. And so 8 squared divided by 8 is 8. And it's negative because negative divided by a positive is a negative. Okay, so there's my acceleration. Now in terms of finding the coefficient of friction, so this is the forces side or the dynamics side of this problem. Usually a good idea to draw a free body diagram. It's going to be the same one as the previous problem, with the gravity and normal canceling out. And this being slowed down by friction. So the net force, which equals to ma due to Newton's second law, again is going to simply equal the force of friction. And we're solving for mu here. So we got to get mu into this equation. That's going to come from rewriting the force of friction as mu times normal. That's the formula for the force of friction. And here's where we change things to magnitudes, because that formula only gives me the magnitude of friction. Going to isolate for mu, so divide both sides by friction. Oh, nope, some mistakes here. Go back. The formula for friction is mu times the normal force, Fn. There we go. And the normal force, looking at the free body diagram, the normal force is equal in magnitude to the force of gravity. So I can actually replace it with mg, which is the magnitude of gravity. Now I can divide both sides by mg. And the m's will actually end up canceling out. So again, I'm given the mass here of 12 kilograms, but I actually did not need it to do this problem. The same answer would apply no matter how massive this box is. Okay, what did I get for the acceleration? I got 8. And this is negative to the right. So this is, well, it just needs the magnitude. The magnitude is 8. And g is 9.8. And we are getting quite a high number here. Just makes me want to double check the math. Yeah, that's quite large normally, I think, for the coefficient of kinetic friction. So let's see, did we do things right? Well, you know what? Maybe I'll find out when some of you send me a message saying, I think I got this instead. Then maybe we can check it out a bit more close. But for now, we're hoping that this is the correct answer for the coefficient of kinetic friction.